Okay, so thank you for the warm introduction and the awesome attendance. I appreciate that. So tonight we're going to go through a few different pieces of the entire build pipeline in software development, right? Some of this may be review for some of you. Some of it may be brand new, which is okay. But I think it's always, this is one of those topics for me that I could rehear once a month and still learn something new. I can easily figure out better ways to do something. So it's kind of an ongoing process in my personal opinion. So okay, so let's get started. So why are we all here, right? Well, we all want to build better software, right? I mean, that's a pretty generic statement on my part, but if you think about it, that's why we're engineers in the first place, is we want to build better software. So why not use all the tools available to us, including continuous integration and testing and deployment, which ultimately those practices will help you build better software in general. So let's talk about the core tenets of each piece, right? So continuous testing is essentially the process of executing automated tests as part of the software delivery pipeline. So that's a pretty big statement, right? But the key piece there for me is automation, right? So it's not just having tests available and running them occasionally, but it's literally automating every step of those. Now, you don't have to run them all at one time. They just have to be ran throughout the entire pipeline at some point. But essentially automating all those tests to where you can continually be testing your code so it's always proper, good, and fits into the rest of the code base. So what are some key pieces, right? They have to be repeatable, right? So being able to write one test and repeat it, and it always gives you the same result based on the functionality. Having a repeatable test is extremely important. Otherwise, you're going to have, if you're always having to come up with like different ways to test the same thing, you want to be able to test that one piece of code with one test and have that always come out. They have to be easy to maintain. So one of the big things for me has always been you get into a code base and there's a whole bunch of tests written. You don't know what any of them really do. You need to go update them. Now it's kind of a pain. You got to go track down somebody or they've left. And so you inherit sort of a mess of just random tests. You don't know what any of those are. So easy maintainability is going to go a long way for making sure you continue to write tests. On the other side of that, however, they also need to be thorough, right? They need to test as much of the application as possible. So if you only test 50% of your code, you're not going to know or have that confidence to be able to ship that code later to know that it's passing tests. So you have to be able to write vigorous testing in the entire pipeline to give yourself that confidence level. And then environmentally consistent. If you're testing on everybody's individual dev machine and then you get it to production, there's going to be slight differences, right? At least that's been my experience. So what you want to try to do is test on a replication of production as close as possible. Otherwise, you're sort of, you don't really know what you're testing. You're just sort of testing something, and maybe it's going to work on production, maybe it isn't. So again, it kind of goes back to that confidence level. All right, so let's talk a little bit about integration, right? So that's the practice of merging developer working copies into a shared mainline several times a day. Okay, so let's talk about what that means a little bit. I go in and I write 100 lines of code, and then Tuesday I write another 100 lines, and then I write another By the end of the week, I got a whole big giant commit. Now I want to try to cram all that back into master branch and make sure it works, right? It's not really a good recipe. It's often how things are done, right? I mean, I've worked with several people who would take 2 or 3 weeks before they would submit a PR, and then I'd have 200 files to go through to try to unpack and debug and make sure they worked, and that was always a nightmare. But if you're able to actually integrate that code on a regular, frequent basis, it's going to point out a whole bunch of things very quickly, right? You're going to know if your code's going to work, if you've broken something, if you haven't broken something. So being able to consistently integrate your written code into the rest of it and make sure that it's going to work is going to save everybody time in the long run. So some key tenets to continuous integration, right? Automating your build. So to be able to do this continuously several times a day across 50 developers, you don't want to have to go in and manually build things every single time a commit happens. So you want to have some sort of build process that's going to be automated. That way, when people do commit new code, they can actually just see that build right away and know if it's going to work. Along with those builds, they also need to be self-tested, right? So we talked about continuous testing already, but taking that continual testing and now running it into your integration build is going to give you that testability every single time somebody makes a commit, so you'll know immediately whether or not you've broken something. Every single commit gets built. Now there's some strong opinions both directions, right? You only build master or staging, or not every single time, but my philosophy is the sooner I know that my commit is not going to work, the sooner I can fix it and make sure it gets merged in properly, as opposed to skipping 3 or 4 and then having to go back in my Git history and figure out what I've done wrong or where I've done it wrong, or maybe it was somebody else did something, right? So being able to do every single commit and build those and run tests will make it a lot easier. It's also much easier to take just taking smaller PRs in general. It's easier on a reviewer. It's going to make your entire team move faster. So just kind of not trying to do the old school method of building, like think of an operating system, right? Version to version, they try to cram as many features in. It takes 8-9 months and they build all these things together and then they ship it all out right at the end, right? Where this is more of the idea of being able to build smaller incremental changes and get those out faster. So then I'll talk about continuous delivery, which is basically the approach of pretty much what I was just talking about, right? It's taking software in short cycles and making sure that they can be released at any point. Okay, now this is sort of the first tenet of actual deployment that's automated, but getting to the point in your build pipeline to where everything can be reliably released, and then maybe you have someone manually release it at that point. Depending on your actual software, that may be a requirement. But continuous delivery, it's also labeled as CD. So it's sort of a confusion between a lot of people on, is continuous delivery and continuous deployment the same thing? But continuous delivery is sort of this point just before continuous deployment that says everything's been packaged, put together, and it can be released. I'm just not automating that release part. So then if you look at continuous deployment, it's actually software that's just released in a fully automated manner, right? So now I've gotten to the point where I've run tests on every commit. I know that things are all being pushed together and fit well, and all my tests are passing and everything's green and good. And then I can get to a point where I can just say, you know what, if everything's good and this is the master branch, just deploy that out. So reliability. Being reliable is kind of a big piece on this part. You're building more reliable software because you're releasing things in smaller increments as opposed to making this massive release that now has become unstable in some way, and then you have to go back and try to debug those things. Whereas if you're incrementally adjusting and improving on that, you're not introducing something that's going to cause major issues that are harder to find. So just mention this one, but incremental improvements, right? So being able to slowly build up a product, it's actually easier on your users in a lot of ways too. Launching these big massive changes and massive features is kind of a headache for some users. They don't really know where things go or why they've changed. So being able to move in a direction, but not go from A to Z, but go through each letter all the way through and slowly build up to that as opposed to just dropping it all at once. And then immediate feedback, right? So going along with incremental improvements, you're actually going to get user feedback more immediately, right? So it's like you'll start to see a certain feature go in a direction, and since you haven't spent 6 months building that feature, right? You've only spent maybe a month or two, and you're slowly rolling things out, and now the users are like, whoa, wait, what? Like this isn't the right direction for us. And then you'll find out from your users immediately whether or not the small changes you've been making have not worked, and that allows you to actually course correct much easier, right? Now you have the ability to see earlier on that the direction you've headed may not be the right thing. So what are some obstacles to all of these? There's always obstacles in development, right? So lack of automation is a big one. There's a lot of moving parts, right? I mean, the more complex your architecture and your systems are, the more individual pieces you have to automate, the more tests you have to automate, the more integrations that have, integration points, the more repos, all these different things, right? So all those pieces have to be built out and automated in some way. So that's a major hurdle to kind of get across initially. Environmental inconsistencies. Be like I mentioned earlier, but having a dev machine that's sort of different than production, or a staging server that's not quite like production. All these different environmental inconsistencies can really be problematic, and make your entire build pipeline fail because you have one setting somewhere that's slightly different, but it works here, not in production. And just the business or management. One of the major hurdles I had trying to introduce this in my last job was we were actually told that we were releasing software too fast for the sales reps to keep up, which was the lamest excuse I'd ever heard. So they're like, let's slow it down to every 2 or 3 weeks, and we'll. It's like, oh my god, are you kidding me? So it was that was a major hurdle. We had to really convince them that that's not the right direction to go, because now what we're doing is we're holding on to problems for 2 weeks that can easily be fixed, but you won't let us change code. And for it was miserable. I don't work there anymore. Thank goodness. Okay, so what are some of the goals? What do we want to get to, right? We need to be reliable, right? We need to know with 100% confidence that our code base is going to be shippable at every point throughout the entire process. Everything has to be automated. The more I have to touch it, the slower it gets, the less accurate it can be, the more errors that I can introduce as a human. And repeatable. I need to be able to do this every single time with the exact same result without question, knowing that if I get 100% successful tests, I'm good to go, right? That's the confidence level that you sort of are aiming for. Not everybody's going to get there, and you're not going to get there right away, but that's sort of the direction, right? So how do we actually get there? That was a slide that needed to be deleted. So Docker, let's talk about Docker. What is Docker, right? Docker is the world's leading software container platform. Does anybody know who said that? Docker. Good call. It's actually pulled right from their website. You know what? I like it though. Let me tell you kind of where I've come from, right? I've spent time deploying software using Macromedia Dreamweaver. Yes, it was Macromedia when I was using it. By checking out code and pushing to one server and then another. I mean, I've done all these crazy things, and I got to the point where I was running virtual machines with Linux for each Ruby environment I wanted. Or full disclosure, I'm more of a JavaScript developer now, but I still can Ruby a little bit. Don't make fun of my Ruby code though if you look at it. But essentially, I got to the point where I was running virtual machines to kind of keep collisions from happening in environments. And then I'm like, oh, well, there's this, can use like Ruby environment. Is it RVN? Mm-hmm. Yeah, RVM. Yeah, and then Node has several versions. I use N, and kind of going through all those different pieces, right? And trying to just separate things out. But you always end up with these little inconsistencies, and one thing's installed globally for one user, so it doesn't make it into a requirements package for this other person, for a gem list, right? So my gem file may have everything I think it needs, but I have something installed differently than this person, and then they have to, it's a mess, right? So all those different little environmental consistencies are a problem. But I was still okay with that, right? I wanted to control my machine. I wanted to know that everything I was building was here and good to go. So I kind of resisted Docker for a while, but over the last 6 or 8 months, I really converted. Because what I've seen is this power where I'm able to put onto my machine exactly what I need it to be. Whatever environment I want to build, I can build a container, I can download an image, I can do pretty much anything I need it to do, and then I can take that and give it to somebody else, and then they can run it. And I don't have to make sure their Postgres is set up the same, or MySQL, or anything like that. So what exactly is a container? Essentially, a container is just, the easiest way for me to think about it is it runs on top of a host OS. But essentially, it's a process, right? So each one of those containers is just its own process. So whether it's a Postgres process or a Ruby process or Elasticsearch process, right? Each one of those is just a specific, where a VM actually also has a guest operating system and adds a whole lot more weight. The containers are very lightweight in that regard. So that's sort of the high level of containers. So let's talk about what it's going to take from here to actually do this as a Ruby app. All right. Make that just a little bigger for you. Cool. All right, so what I'm going to do is start with a Docker file. So on this, I can't make this any bigger, unfortunately, on this side, so bear with me. But over here is essentially, I built a Rails API application. So you'll see all these files over here on the left, and I kind of had it all running locally, and everything worked. And then what I wanted to do is take that and make it into a Dockerized container, so I could develop in Docker. And then eventually use that through my entire build pipeline. So I'm going to just kind of go through each step of this. Some of this, who all in here actually uses Docker and containers on a regular basis? Cool. So this is not going to bore 95% of you. The other guys, you can go grab a slice or a beer, whatever you need to do. Okay, so this top line is basically, this is an image that comes directly from Docker. Okay, so Docker has, I'm going to flip back and forth here, so I apologize for that. So there is a Docker store, and in the Docker store, we can get all kinds of cool stuff, right? So if I go in here and I search for Ruby, I can find all of these nice containers from Ruby directly. So you'll see there's different versions. Sorry, I'm getting a little crazy there. There's different versions you can pull in, different flavors of Linux you can use. So like Slim and Alpine, they're stripped down versions of Linux, so that you can get a lot smaller. And then it kind of goes through, tells you everything about Ruby, and then how to use the actual image, right? How to create a Docker file, how to end up with everything at the bottom that you would need. Okay, so but what you're going to look for is if you need a specific version of Ruby, you're going to look down this side, find that specific version, and then you're going to copy that tag. So over here on my from line, I'm using 2.4.0, and I'm using the Alpine flavor, so I want to get a real small image when I'm all done. Now, the fun part about a Docker file is as it goes from top to bottom, it's making a new image, which is cached. So let me explain a little bit how that works. Each time I run the build process for this Docker container with this Docker file, it will get faster if nothing changes. Okay, so if nothing changes on the run step, that will be cached for me, and then it will pull all that in. If that changes, everything below that gets reran, so it'll be a little slower. But essentially, top to bottom, if nothing changes, it'll go all the way through. And then with the first point moving downward that gets broken and invalidates that cache, it'll rebuild from that point. So the first thing I do is I use a command called run, which is going to basically run a bash command. In this case, it's actually just sh. So this is the Alpine package management. I'm going to make sure all my packages are up to date, and then I just add the packages I need for this particular image to run the Rails app that I have. There's actually a Rails Docker store image, but I wanted to do this a little different. So if I do Rails, let me search for that. There's like several out there. I thought there was an official one from, may not be actually official, which is probably why I didn't go that route. But there are ones that you can find that already have a lot of this stuff baked in. So you can just kind of get Rails set up already on an image. Sort of the fun part is finding images that are already built on top of Docker. For this particular instance, I just installed these different packages on my Alpine machine. And then I actually, at that point, I make a new directory called app, and I switch that to be my current working directory. Then from everything here, it's all in the /app folder. And then I'll copy my gem file. Now this, what you'll see here is it's kind of two different sides. So I have my copy, and then I have host, and then I have container. So on everything you see on like the left side is going to be my host. So this gem file it's pulling is actually my gem file right here, right? So everything that's here is what's being pulled in. And let me close this. Okay, so I copy that over. So this is where that cache probably will make the biggest difference. Everything up here is mostly going to stay the same for me. It's not going to change, which is sort of the way you want it. You want the things up high in this Docker file that are going to change the least and be the most stable. My gem file, however, when it changes, the cache will get invalidated at this point, and it'll bring over the new gem file. So if I add new gems, it'll also bring over the lock file, and then it's going to finally run bundle install. Once bundle install is done, it's actually going to copy all of my code from the entire root directory. So everything over here gets copied all the way over into my app folder now on my container. So to take a look at what that looks like, okay, I'm going to just do Docker build, and I'm going to use that to build. So what it's going to do, what you'll see here is it's going to download from Docker Hub in the Ruby library. It's going to download that container that I specified in my first step. So you'll see it's like step 1 of 8, which corresponds directly to these 8 purple commands over here. So from, run, work directory, copy, run, copy. Right, so those are my 8 steps. So this is going to be like watching paint dry for a moment, so give that a second. Actually, while that's building, yeah. Because of cache validation. So if the gem file hasn't changed, it'll stay there and then install like basically the bundle install and all that won't have to continually rerun if that hasn't changed. If I copy all the files over, those are very volatile, right? Those are going to change quite frequently. So that's where you get that benefit of cache. So great question that I forgot to repeat. I'm already failing you. I'm sorry. They told me to repeat all the questions and I completely forgot on the first one. It was a test. Now when when everyone else asks questions, I'll remember, or probably not. Okay, so this is going to be really boring to watch, so we're not going to watch it. But essentially what this is going to do is it's going to go through and it's going to build a container that will run my application, okay? The hard part here is I also want to run my database at the same time, right? So then what we used to have to do with Docker is you'd have to set up networks and kind of do some fancy stuff all by yourself. And they created what's called Docker Compose. Now Compose, what it allows me to do is sort of specify various services and then connect them together and use them all at once. So let me walk you through what a Docker Compose file looks like. So this is sort of the basic outline of it and the shape. So it's going to have a version at the top. They're on version 3 now. I'm using version 2 because it's sort of what I started with and I haven't really migrated over, although most of the commands in version 3 are fairly similar. It's also the same syntax that when I get to my build on Codeship, we kind of mimicked version 2's syntax. So it just kind of kept me sane while I was developing it. But essentially what I'm going to do is I can define under services in this YAML file, I can define as many services as I need to run all at the same time. So Docker Compose as a command line tool will let me run a command called up. And when I run up, it'll start all of these services, network them together, and allow me to use them as one sort of local server, for lack of a better word, but each one becomes its own individual process that gets linked together. So let's look at web first. So this is just my Rails app. I can actually call it, you could have called this API, you could call this Rails, you can call it, you know, whatever you want to call it. It's pretty arbitrary. It's just the name that you're giving it, which becomes then the alias for that process in the network. From here, I'm giving it a build step, which is going to look in the root directory for a Docker file, right? So when I say build, it's going to build off of the Docker file that we just created. The next piece is it's going to run a command. So when it builds the web process and everything is built, let me kind of back up a little bit and talk about build time. So what you're seeing over here with this is the build time for a Docker image. It's building everything onto and creating this image that will then be ran as a container. When it's run, now that becomes the runtime, and there are slight differences when that happens. But essentially, Compose sort of pulls those two things together, and it builds. It'll run the build for you, and then it will also do the actual command to run the service. So the command that I wanted it to run is just bundle execute Rails, and then with the local host as 0000 for the port. The port ends up being 3000, which I'll get to in a second here. And then volumes. Okay, so volumes is another nice thing. What it's telling me, and it's the same sort of setup as it was in the last one with the host and containers. So if you see here, this is actually host and container. So on this side, it's tying my root directory of this actual, just my entire directory here, this folder, to the /app, which from the Docker file is my working directory. So I made that directory there, and then I'm tying this volume. And what essentially is going to happen is while that container is running, it's essentially going to look at my local machines files, and anytime that changes there, it will mimic that in the container during runtime. Now, if I shut down that container, I actually then have to rebuild it to grab the new files, right? So that's sort of how that copy works. It'll grab all those new files and then save those in the image. So from here, I then open up, I guess is a good term for it, open up the ports. So again, it's the host and container for left, and on the left side is the host, and on the right side is the container. But I'm essentially networking my machine's local host 3000 to the container's 3000 port. So the container opens up 3000, and then I connect my 3000. If I change this to 8080, right, then I would just type in localhost 8080, and it would connect to the container. But that container is still only opening port 3000 to me. So it's sort of the way that works. I'll leave it as 3000. And I set up a database URL as my environment. So with this, this actually is using the networked alias, which is my service down here for Postgres, to do the connection. And then in my configuration, I actually just parse out that URL. And I only use the one. I don't create like a test or a staging database or development database or anything like that. I just use the one. So if I go into my db, not db, config database. Yep, so I actually just fetch the database URL here and leave it as that. So I don't really do a whole lot else here. Pretty much just everything goes off of the same database. And I'll show you why in a second. But the nice thing about containers is they're ephemeral, right? So I can create multiple containers all off of the same setup and throw them away pretty much at will. And they're always the same, right? There's no like guesswork. I don't have to change anything. I don't have to have different environments for test or development or production. I just sort of use, everything's the same, right? So there's that sort of environmentally consistent development process that I want to get to. Okay, so all the bundle, everything from the bundle and the gem file installed, that process finished. I now have an image, Docker images. Down here, this is, okay, so this is the Ruby one, and this one is not tagged and not named, but that's the one that was just built based on the SHA E581, E581 at the top. So I know it built, it's 371 megabytes right now, which is pretty tiny for everything that went on and got installed. But essentially, I have an image, and I can run that. I can run that image, but I don't have a database. I don't have anything else, right? So it's sort of that's why I'm doing the Docker Compose piece. So let me finish up that, and then we'll run Docker Compose. Actually, I'll run Docker Compose up now. All right, so it's going to build out that container again, which should mostly, I need to turn myself down, hang on, there we go. So that's mostly going to take, I'll take a couple minutes just to finish up, but what it's going to do is it's going to start by building a web service, which I just defined everything here and kind of walked through. And then the Postgres side of things. Now this one is very similar. So it takes an image like that same from command in my Docker file, but instead of me writing a separate Docker file for my Postgres service, I can just call that image directly. And I can do that with pretty much any database I can find over here. So if I go in and do MySQL, I'm going to find there's a MySQL, and I can use that specifically. I can just call this. I can use version 8.0.1. Boom, there it is. I can do the exact same thing. Now I can, plug into a service with Docker Compose anything I really need. So Elasticsearch, Redis, Memcache, I mean, any kind of service you want, you just find it on the hub, and then you can use that image. Now the fun thing about this particular Postgres image is it has, so it's got the same kind of thing that Ruby has, and then under its reference and how to use, it actually talks about there's some environment variables that you can pass in. So if you define these environment variables, you can customize that particular image without having to do a whole lot of extra work. So you can set up where like PG data is stored, you can set up the name of the Postgres database, all the different stuff here, the default user and password and all those kinds of things, which I actually do here. I set up a user and the default user and the default database as to-do, user as to-do app and the database is to-dos. So that's it. Like I didn't have to set up Postgres locally or configure it or make sure it was running and all that mess. I just put it in here. And then when I run Docker Compose up, and eventually, so right now it's pulling Postgres. It's built one of my things already. Oh, it just started running, hang on. Show. Okay, so what I do is I'll have, okay, cool. So it shows my logs for my Postgres and my web. So it booted Puma, Rails 502 application starting in development mode on 3000. I could probably change that development mode to I could probably change the development to production here because really realistically it doesn't matter. I just didn't really change it. But you can actually run this in as production because that's sort of what you want to get to is you want to make this your production server locally for development. So if I go to my other window and I do Docker Compose PS. Yes. Well, yeah, maybe that's a good point. So that was a good question to repeat. So essentially you're asking why would you run the local machine as a production environment when development does specific things in Rails? And that's a fair point. So I guess what I'm saying is if you ran it in production and you didn't need the extra tooling that development would bring in the development environment, you can get away with that here and then know that when you're actually deploying it, it's going to work as the production environment. So a lot of times some of the bugs that I see that get introduced are because you're doing one thing in development and not accounting, it doesn't get accounted for in production. So you sort of push code out that works great in development, but not in production. Yeah. Yeah, I'm not going to give really great Ruby examples, but I know from like my experience as a node developer, I've seen ones where, you know, it's one version of a module that's used in development that doesn't make it to production properly, or you kind of leave things on one side that get included in development, but then they're not actually included in the production, but they needed to be there, like a requirement or dependency kind of thing. Dumb stuff like that can happen. Okay, so like, yeah, so logging, that's a fair point, right? You're going to turn on everything for logging and get every last minute detail. In production, it's going to be a little different. Is that kind of what you're thinking? So okay, so you could still do one container. You would just, if you're deploying okay, so I'm working specifically in the development environment. So maybe in this particular instance, running it as a production environment might not be great because you're not going to get that detail that you want in development mode. That's a fair point, and probably an overstatement just on my part to say run it in production. Getting that consistency as close as you can, though. So, I mean, if it's minor things like that, if everything else is basically the same as production, you're probably good, and you're only flipping certain things. Otherwise, you know, you don't want to have your production and your development environments too far apart. Yeah, maybe. Although staging for me has never been a solid production replication either, so it's kind of a catch-22, I guess. Yeah.
But you're advocating, like, I assume we're then going to use this production Docker container to be like continuous integration.
Yeah, eventually you would.
Wouldn't you be just developing in your regular development environment and then continuously pushing, building just the code in the production environment, you know, so that you know that this container is the same container that's
that's certainly one way to do it, is to have, okay, so to have the code, basically code on your local dev machine, and then use the Docker container as the production. And so you could do it that way. I'm actually advocating to use the Docker container to run all the time, and then you can. So what I'm advocating mostly for is to not have to install gems on your local machine anymore, right? Or control what environment you have to use. It's the same as using like Vagrant or a just an actual VM virtual box kind of thing, right? It's the ability for you to say this container runs this specific version and all these different things, and it's all installed there, and I don't have to install anything on my machine anymore. So if you want to run it as development, you can actually have, and if you end up deploying on production, right, deploying it as a production Docker environment, you would probably have a secondary Docker file for that production to run a different command and specify that it was running in like a production environment at that point. Does that make sense? So you could still have it both ways. The trick there is you're basically going to then just switch that it's development production Rails, and you're not really changing anything container wise, or like the host itself is consistent as possible. Yeah. Okay. That's fair. And your specific need is going to be much different than mine. And I'm sort of doing this more as an example and not as like a hard and fast rule. So if you want to Yeah, in the gem file itself, there's places to separate out what's for test and what's for production, right? Which ones get installed. So when you're going to a production environment and installing only those production ones, you want to make sure that you're just flagging it as production and it's not installing all those. The container itself, though, is going to be like the same version. It's going to be the same Postgres, right? Like those things, like you set up using code and you configure with code, but the gem files and all those sorts of things, that's flexible.
It's quite common to see that it's not up to the same baseline, but then they have a development system on your trace and open. I think the main point is to try and have them as to the test at any level as possible. In fact, you can actually bring down all three of them, have tested based on CI production. You could run production mode, but not all the tests you fire up.
Right.
Why is it not running production? Well, that's why. But it's definitely got very specific tests set up, use volumes, formulate your local file system, changes to the file as well. But once you get to the design, you might want to do differently. You can design on the host environment. That's fine. Package differently, maybe without the full file. Have a buffer, just jars, wide, whatever you want in parallel. But then when you went into production, you don't want all these things done. You don't want all those to be production. But the main thing is just to set everything up at once. All the rest of
My example is fairly simple, like it, and by fairly I mean it really really simple. So you can get pretty complex. So yeah. Mm-hmm. Okay, that's fair, and you're probably not alone. But for my example here, my simple example is just on this. So your mileage may vary. I think is the lesson learned here, right? Not everybody's going to have the same result. Okay, so let's have a look at. So essentially, at this point, I have pretty much everything going. The only thing I need to do is I need to actually go in and run a command on this box. And what I need to do is grab, because I haven't done this in a while. So I need to actually run my db migrate. So Docker Compose allows us to, that's where I needed to stop right here. It actually gives us a command called execute. So it's going to point to my web service, and then it's going to run the command bundle exec rake db migrate, right? So I'm going to hit that now, and everything is migrated. And then at that point, I should be able to go to localhost 3000 and get no, so that worked. And then if I go to /todos, yep, I get an empty array, right? Because I don't actually have anything in there. Just because I haven't really written anything for it. But so it's basically a clean, fresh start of my API and my database. So from here, if I want to run, I have a way that I can run testing as well. So as I'm going through, I want to run tests, and this isn't terribly automated on just mostly because I haven't really set it up that way. But Docker Compose also gives us another way to spin up new containers on the fly. So what I'm using is run, which will create a new container and run the command that I give it. And unfortunately, you can't just run it straight from the current folder structure because it's going to use this Ruby Rails to do app, which is already used up here as a project name. So I give it a new project name called tests, and then I'm going to change the port. No, this actually is going to bind to the port 3000 on the container, but it's going to randomize the port on the host, so I can sort of, I don't have to really worry about that. All I want to see is the output of RSpec in this case. So I'll hit enter. It's going to build that out. And completely fail. Sweet. Why did that fail? Postgres address name does not resolve. I'm actually not sure why that failed. I'm gonna have to go back and figure that out. Used to work. Sorry. The love of a live demo. Okay, so Docker Compose. Essentially, what you're doing there is you're going to run a new set of containers that will actually run RSpec and show you the output. Why it's not working right now, I don't know. But that's something I'm going to have to figure out. So there is no. Honestly, I don't know why. Like it normally just works, and I didn't test it this morning, so that's my own fault. So I must have done something incorrect. I don't believe I have to migrate in this case because it was migrating in my RSpec tests. It's been a while since I wrote this, so but I'm pretty sure I have like a thing that sets everything up to begin with. So 1 hour. It's 8 p.m. Man. Okay. So let me fly through 10 more minutes. Everybody okay? Okay. I don't want to bore everybody to death, so we kind of went a little long there. Let me just I'll go through the rest of this on how like the CI portion works, and then I'll give you a link to our ebook that kind of goes through this whole project and let you figure out how to set it up, and maybe it'll work for you and not for me. That's how that works. Okay, so a couple of things. I have, when I'm automating this, I'm actually going to write some shell scripts to help me automate things. So one of the things I wrote a shell script called wait for Postgres because during the process of firing everything up and starting it, Postgres isn't always ready to accept connections immediately, so I have to wait for that. So literally, I just make sure it's ready, and if it isn't, I wait, and then I loop through, and it's kind of cheap, but it works. Once that's done, then I can run like db create, migrate, and seed if any of those need to be ran, which mostly I just do migrate. And then it will go through and run whatever command I send it after that. So that's the part, that's the shell script that I run during my CI process, which I will show you in a second. The services file for Codeship. So this looks very familiar, looks very similar to the last thing we just opened up with the Docker Compose file. But essentially I have, it's gonna build from the local Docker file, it's gonna link to Postgres, it's going to set up my environment variable for a database, and then it's gonna set up my Postgres database, my Postgres user, all those kinds of things. Then it gets down to this bottom piece here, and now I've added a deployment service as well. And this deployment service is going to pull down our Codeship Heroku deployment image. And then I have an environment file that's been encrypted locally. And then when all of that it runs, it's going to use a steps file to sort of walk me through a few different things. So I'm going to run in serial, which this is a little hard to read this way. So I'm going to do a parallel step initially where I'm going to do RSpec and Rubocop just to test those. And if you notice here, I use that bin CI script before I run RSpec. And then that will make sure Postgres is running before I try connecting to it. So then after here, once these two parallel steps pass, if it will continue down the steps file to see what else is left. In this particular instance, this deploy step is actually only going to run when the tag is exactly equal to master. But we have ways that you can match tags with various templated, like regex and that kind of thing. And you can also exclude or include that kind of thing. But once it gets down to this deployment step, if the tag is master, it will run my deploy service. And in that deploy service, we have some scripts available that will run, and you can run this command called deploy. It'll take the deploy folder and push that out to my Heroku application that's already running. Once that's done, I run a migrate step, which will automatically deploy, and it will run a Heroku command for me directly. So it will just go through and run any migrations that need to happen. So when all that happens, I'm going to do some cooking show coding here. Code when it actually worked. Oh, nice, we changed all this, I forgot. Look, everyone, it's a brand new login page. Cool. All right, so let's go to projects and Ruby. And there we go. Okay, so let me blow that up. Too far, too close. There it is. Okay, so here's my services, right? So it shows you the services built, my web built, and it's very similar to what we saw earlier when that Docker file built. So it kind of goes through, runs through everything here, pulls down my Postgres, gets everything all set up, ready to go, and then it runs through my steps. So here is RSpec when it actually works. So 15 examples, no failures. That's what it should look like in my command line when this actually happens. So I'm not really quite sure what I missed, but I need to get that fixed. And then Rubocop ran, 21 files expected, no offenses, so good to go. So those two things got checked, that parallel pipeline got checked. So then it goes on to my deployment, looks for the application, shows that it's detected as Ruby, compiles everything, shows me the deployment was successful, runs migrate, good to go. And if I go to Ruby Rails to do app / to-dos, I wait for Heroku to wake up because I don't pay for it. Don't tell them that. There it is. So that's the actual API working in a on a Heroku app. Pushed all the code out through Codeship. All I had to do is make a commit to master branch, and all those things ran. If I do it without master branch, you can see at some points. So like this one, it didn't actually have it, but everything's actually done straight to master. So I can't really show you an example of that in this particular one. But there are other ones where you'll see like API, like here's a non-master branch and it does different things. And skips things and doesn't skip things and that kind of stuff. So we have the Dockerized version, which is our pro version, but that's sort of what this all walks you through. And then I'll give you the quick link here. So if you want to download the book that kind of goes through all this, feel free to ping me if things don't work for you. But that's the link. You can write that down and go download that, and it'll walk you basically through everything we did tonight, kind of point you in the right direction, and at least get you started, which is sort of what I was looking for 6 months ago, was sort of a get started guide that I couldn't really find. So other than that, we can open it up to other questions, which I can fail miserably at answering. Yes.
So you had sort of like a wild loop for basically just pulling the seed. Postgre was up and running, but is there any sort of like evented kind of communication that can happen between containers, or do the containers always have to talk to a specific port on another container to some other app that's running in that container? So the containers communicate with each other through sort of a higher level.
Okay, so the question is, how do the containers talk to each other? There is a network that gets created through Docker Compose, and each one of those services becomes an alias for that network, on that network. So like I connect to Postgres directly, and I call it Postgres, you call it Postgre, which is throwing me off. Now I'm like, have I always been wrong? Is it GIF or GIF? I don't know. You could be right. I have no idea. I'm sorry. I'm digressing. So I actually connect to the host Postgres, which is the name of my service. I use PG is ready because it was just the right function I felt to use to make sure Postgres was up. And it was also kind of hacky and fun, and I did it really quickly, so it works out. But yeah, the actual environment file for the database URL is at Postgres, right? So that's how those communicate. So the network name is the service name. When everything is said and done, it aliases to that. So you can communicate like that between the two things.
Container, say the Postgres container, it couldn't then raise some sort of event that says, hey, Postgres is ready, if anyone cares, it has to be asked.
Does it do that? That's the heartbeat, right?
Yeah, the
health check.
health check, yes.
That's right.
Thank you. Yeah, so there's a health check option. It's been added a couple months ago or something, where you basically add, if I remember correctly, you add a special script to say, I'm now alive. And then you have that whole ecosystem going. So Docker Compose will basically wait with the subsequent services. If you say, oh, I'm waiting for this guy up here. So it waits until the health check says, yep, I'm good to go. And then it actually starts the other one. There's another in-between one that's called depends on. So you can say this container depends on that container, but it doesn't actually wait for the service to start, but it waits a little bit longer than it does now with just pure links. It's kind of, yeah, no, it doesn't wait for the database at all. Just
the container is up. The container is up and ready, but the database may not be. So that's a V3 health check is, I believe.
No, so there's wonkiness with V2 and V3, I think. So as far as I understand, V3 doesn't replace V2, but adds a bunch more, specifically when you start doing swarm, hundreds of containers at the same time and like really massive deployments of it. We've decided to stick to version 2 because for a CI environment, you don't need massive swarms of containers. You just need a couple that starts up and tests stuff. So I don't think they're superseding or one has more than the other. It's different targets. It's really confusing. So, yeah.
So the health check it's actually really cool. I haven't played with it much because I haven't tried yet. I'm still pretty new to Docker, like relatively. I mean, under a year, so it's pretty new to me too. From what I've heard, health check is great. What Codeship doesn't support it yet, so that was sort of the reasoning why I just went with this. But yeah, that does exist. I just didn't immediately come to my mind. So thanks.
It's coming.
Anybody else?
in this example, you deploy to Heroku that actually doesn't care about the Docker image, right? It just takes the code. Do you support like any other providers, or are there any other providers that you can just like put for Docker images?
Yep. So we'll do like Quay or Docker Hub, AWS, any of like EC2 or what's the other ECS.
So there's a specific in
knows all those.
in the steps file. If you switch to that one,
Yep.
There's a special type of step that we support. It's called the push step, which will take the resulting image and push it to whatever repository, registry that you want. So AWS, ECR, Google, Quay, Docker Hub, whatever.
Yep.
So basically, we would allow you to build the image, test it. If it's all good, you take the resulting image and push it somewhere. Usually, you would then trigger off the push of a new image would trigger a deployment to the target environment. I think we could push to target environments as well. We've got the one that Kelly used as an image file, Codeship, something Heroku. Got a couple of those, Heroku and AWS. And I think a Google one as well, but I'm not 100% sure on that one.
Is there a way with those providers to map Docker console to an actual like set of servers?
Not 100% sure on that, but I believe there is. But then you're moving into the area of like Kubernetes and orchestration of containers, and then you're into a completely different realm than what we look at from a CI point of view.
Yep.
But yeah, there is ways of defining once it's in production. I want X number of web containers. I want X number of whatever cache containers.
So on the deployment side, here's like a short list of examples we have there. So with AWS, Azure, Heroku, Cloud, Kubernetes. I actually did one that was SSH deployment, and I just sort of rsynced files from our CI server to another one. That was kind of fun, but pretty fun stuff. Anybody else? Awesome. Thanks for your attention tonight, and I appreciate everybody. So, cool.